Alright guys, this is the start of the second video for section 4.1. So if you haven't watched the first video already, please stop this and go back and watch the first because this one probably won't make much sense without watching the first one first. But if you have, go ahead and do A on your own. We've already done some of these together. I just want to make sure you can do it on your own. So name this vector over here and write it in its component form. All right, so you should have got vector bk, so it starts at b and then it goes to k. If you wrote vector kb, that is incorrect. Okay, now when you're writing it in component form, remember you have to have these squared off brackets right here. You can't just have parentheses. So the -5 meant that I went left 5, so I went 1, 2, 3, 4, 5 left. And then the +2 here means I went up 2. So that vector basically said I went left 5 and up 2. All right. All right, so here it gives me the vertices of triangle LMN. So I'm going to write L, M, and N here, okay? This doesn't call for me to graph it, so I don't have to graph it. If graphing helps you, which most of you will, please do. So I know L is at 2, 2. I know M is at 5, 3, and N is at 9, 1. Okay, so I want to translate this triangle using the vector -2, 6. All right, so if I transfer it using the vector, let me switch colors here, that means I would get an L prime, an M prime, and an N prime. Remember, the primes come after we do something to it. So this is going left 2, this is going up 6. So if I go left 2 from 2, I would be at 0. And if I go up 6 from 2, I would be at 8. And then M prime, if I go left 2 from 5, I'd be at 3. And up 6 from 3, I'd be at 9. And if I go left 2 from 9, I would be at 7. And up 6 from 1, I would be at 7. So these would be my new coordinates. And once again, if you want to plot it and double check, or if you just want to plot it just to get these numbers, that'd be perfectly fine too. You'd probably be less likely to make a mistake doing that. All right. So here we have a vocabulary word that's the rigid motion. I believe our book calls it a rigid motion. Most other books call it an isometry. So either thing, they're the same thing, just different word for it. So anytime you see either one, it means the same thing. And all that is just an operation that maintains size and angle measure. Okay, so basically, like a translation, we move it, but we're not changing the size and we're not changing the shape at all. So that would be a rigid motion or an isometry. And then the translation postulate basically tells us that a translation is a rigid motion. This should make sense. We can translate something anywhere on the coordinate grid and it's still going to maintain a congruent shape. The shape of it is not going to change, only the location that it's in does. All right, so next we have a composition of transformations, and all that is when we put 2 or more transformations are put together, or you can put combined, that probably would have been easier, are put together to form a single transformation. We'll do a couple examples here in a minute. And then this theorem tells us the composition of 2 or more rigid motions is a rigid motion. So if we have 2 translations put together, it's still going to be a rigid motion. That should make sense as well. All right. So it says graph segment RS with endpoints R, -8, 5, and S, -6, 8, and its image after the composition. So notice we have 2 different translations. All right, I know it says to graph it, but I didn't put a graph on here, so I'm just going to write the coordinates. And I'm positive that if you can write the coordinates, then you can graph it. Hopefully by now we can graph points. All right, so I'm just going to put what we're starting. So we're starting at -8, 5, and then S is at -6, 8. I just took that straight from what it tells me here and here. All right, so our first translation, and we always do it in the order they tell us, here's the rule. So in words, I want to ask yourself, where does this rule tell us that we're moving? This rule tells us that we're moving right 5 and we're moving down 2. Okay, so I'm going to make my R prime and my S prime. And if I'm moving right 5, my -8 is going to go to a -3. And if I'm moving down 2, my 5 is going to go to a +3. Then right 5 from -6 would be at -1. Down 2 from 8 is 6. So now I have my R prime and my S prime. All right, so now I'm looking at my second translation. Okay, so my second translation is x comma y goes to x minus 4, y minus 4. So in words, what does this rule tell us? Where are we moving using this rule? This rule tells us we're moving left 4 and down 2. Okay, so now I have my R prime. Guys, I'm going to get my R double prime and my S double prime. Okay, so if I'm moving left 4 from -3, it would be -4. If I'm moving down 2 from 3, it'd be 1. And if I'm moving left 4 from -1, it'd be -5. And down 2 from 6 is +4. All right, so let's look at this one. Good old word problem. It says you were designing a favicon for a golf website. In an image editing program, you move the red rectangle 2 units left and 3 units down. So I'm going to write that down here. First we go 2 left, 3 down. Okay, that's the first thing we do. Then we move the rectangle 1 unit right. So I have 1 unit right and 1 unit up. All right. So if I were to write these in separate ones, I'd have x comma y goes 2, x comma y goes 2. Okay, if I go 2 left, that'd be x minus 2, comma, 3 down, y minus 3. Okay, on number 2, if I go 1 right, it'd be x plus 1, and 1 up, it'd be y plus 1. However, that's not what the question asked. I want the rule of the final translation. So it says rewrite the composition as a single translation. So rather than doing this and then stopping and then doing this, I want to just do it in one. So I'm going to say x comma y goes to, anytime it wants the rule, we put it in this form. Okay, so if I move left 2 and then right 1, really I would just move left 1. Okay, so left 1 is x minus 1. And if I move down 3, but then up 1, total, I'm really moving down 2. So that'd be y minus 2. So that would be my final rule. If I wanted to write that in component form, so component form signifies that you're translating it using a vector. If I want to write this in component form, remember these square-ish brackets, pointy, whatever you want to call them, it would just be -1, comma, -2. All right, I want you to go ahead, do this one on your own. We've done several examples. You should be able to do this. I'm going to pause it, let you do it, and then I'll show you what I got. All right, guys, this is what I got. So the first thing I did is I graphed TU, which is in red, and then I read my rule. So this basically says I'm going left 2 and down 3. So from T, I go left 2, down 3, and I get T prime. From U, I go left 2, down 3 to get U prime. Okay, so I'm done with this translation then. Okay, so that's my T prime and U prime. Now it's time to do the T double prime and U double prime. So I want you to make note that you start, when you're going to use the second translation, you start with T prime, U prime, not your original TU. Okay, that's very important. So I'm going to go from this and this point. Okay, then if I look at this translation, I'm going to go left 4. So from T prime, I go left 1, 2, 3, 4, and I go up 1, 2, 3, 4, 5. So here's my T double prime. And then from my U prime, I go left 4, 1, 2, 3, 4, up 1, 2, 3, 4, 5. Here's my U double prime. So here's my T double prime, U double prime. That would be my final solution.